So the goal of this last piece was just simply to tie stuff together. And so the way I started to try and tie stuff together was to stop and say, well, what are we actually doing? And we're writing build a WeBWorK problems, and they have these various sections with tagging and description, initialization, setup, text, and then something with hints or solutions or what have you. And the only piece of this that we haven't spent a lot of time talking about is the very first one, which is the tagging the problems. And I, for a very long time when I was starting to write these, didn't really worry about tagging the problems terribly well. And so what I tried to do was put in some sort of description, like that first little stanza where I have description and about what the problem actually is. All of the tags with the double hashes and sort of the leading thing that looks like a function call, like keywords and DB subject and chapter and so on like that, are actual database tags. And so this is not a terribly simple set of tags, but it's the type of thing that I just sort of block in even if I'm not putting it into the OPL immediately. And if I put them into my template, then it means that when I'm editing on new problems, that they automatically inherit the right set of words at the top of the file so that I know what I'm doing. Mike talked a little bit about this and pointed out the ability to turn on the tagging drop-downs that show up in the problem file. The labels that he was showing you there are mapped directly to the labels that are showing up in here. And so if you're trying to tag something to eventually go into the OPL, the four things that have to be there are a DB subject, a DB chapter, a DB section, and a level. And the values for each of these are prescribed. So there's a list somewhere that tells you exactly what they have to have in them, and it's probably on one of these wiki pages that I've listed at the bottom of this file, this page. This PDF that I'm going through right now is already in the shared drive on Google that we've got. And in a minute, I'm going to jump out of this and go into WeBWorK to try and show off what's some actual action doing stuff. But this felt like a more efficient way to do this right now. And then the keywords, title text, and so on are optional, but they're really handy if you're actually coding stuff that looks like an actual textbook, because it means that when somebody else comes in and searches the library, they can see what the actual textbook it was that you wrote it from. And so, for example, I mean, what it means is that the people who have done this mean it results in certain textbooks appearing to be extremely well represented in the problem library, and others seem not to be, but a large part of that is simply who put the tags into their problems. And so the Hughes Hallett calculus book, you find quite a lot of those, but a lot's because the people that were writing those problems largely put the tags in for the textbook, and many of the other ones don't have the same level of tagging. This page here is going back to sort of, we talked about the distinction between PGML and PG, right? And so PG sort of lies underneath the PGML that we've been using. And this problem I put in for two reasons. One was simply to reiterate some of the stuff that we've seen before, which is to do things like create graphs and set up multi-answer checkers. We're using the PG code, that all of the macros that exist for just standard problems, and then we're using them quite happily in a PGML problem. And so this one creates a graph and then uses a multi-answer checker to check the answers for the problem. It's a bit of a fabricated problem in the sense that I put it in simply because I wanted to use two different things out of the PG libraries. But it has two desirable features, one of which is it uses this multi-answer, which David said was one of his favorite macros, and I have to say is one of my favorite macros as well. It is just phenomenal how useful this thing is, and how many times I use it. I think sometimes I use it when I shouldn't, because actually there's a better macro out there to do it, because it's just so cool and I like doing it. And the other piece was when you're inserting images, this has come up a couple of times, which is images are not, in their own nature, by nature, they're not very accessible. So if you have people who are coming in with screen readers and things, then you run into trouble if you're relying on graphs to communicate information. And so I try very hard when I'm writing graphs to include this extra HTML tags alt equals stuff in my image call, because that then is this thing here. Oh, no, it's not, sorry. There we go. Okay, so on the top of the right-hand column there, it says alt graph of an upward opening parabola with vertex x equals x naught. And so this is, the whole point of this is so that if somebody is seeing the graph through a screen reader, they get some text that tells them at least something that's useful to try and figure out what the heck's going on. And my experience is sometimes the alt text is almost giving the answer away, but at the same time it feels like it's probably appropriate to get something there rather than nothing at all. And the others, I have solutions. I like solutions. I think everybody should put solutions in. Okay. Oh, and the other thing I wanted to point out is both the graphics and the multi-answer. So I'd say I love putting multi-answer problems in. Almost every time I end up going out to the problem techniques page to figure out what the actual syntax is for these. And so I encourage you, if you're trying to write these and you say, man, I can't remember the syntax for multi-answer, I must not be doing something right, then I think you're probably not right, because that's what I always do anyway. And it may very well be for a lot of these things, David's really the only one who can do it without thinking about it. All right, so more notes on problems. So this is getting back to the, how do I write problems that are good in some sort of general sense, right? So an aesthetic, how good are my problems type of sense. And I have a few notes about that. One is, if you start from problem templates that you have made or that other people have put together for you, then you end up with a good basic structure that means that you're going to have nice looking problems, and it also decreases the pain and agony of forgetting to load macros and things like that. We now have a couple of crib sheets which may or may not be useful for both PG and PGML in the directory, which may be helpful. And there are lots of resources out there which we've been showing you, and I'm going to show it again in a minute. David says he looks at the code, right? Okay. So my first other things I wanted to say about problems, I'm a huge fan of commenting, and so I tend to comment my problems as much as possible with the goal of making it so that when I go back and look at them a year later, I know what the heck I was doing. And so this is a sample for a problem that I was writing last week, I think. And so my first thing was, what are we actually doing? We're solving a 3x2 system. This is a linear algebra problem, right? The reduced row echelon form of the problem that we're giving you is that. Here are some variables. Here's the solution. And then the way I'm calculating the system that I'm giving the student is I start with the reduced row echelon form and then perform, what did I pick? 3 operations on that. And the operations I'm picking are, operation 0 is take a constant of the first row and add it to the second row. The second operation, or the first 0, 1, is negative k1 times r2, 1 times plus r3, and I take negative k3 r2 plus r3. Or I can multiply one of the rows by a constant multiple, and I pick 3 of those. And then you can't, I didn't put it in the code down here, but if you go further below the constants here, all it does is perform these row operations on my rows, and then it uses that to generate the system that I give the student. And the result of this is that it means that I know exactly what the student's answer is going to be. I know that it's going to be nice because I set it up so that the x and y coordinates that I'm asking them for are these nice values. And I'm also setting it up because I know exactly how many row operations that they've had to do to get there. I know that it's not going to be a horrendous task to get through the algebra to do it. And so this is what I meant by think about problem answers. Including hints and solutions, I think, is always a good thing. And considering accessibility, I think, is always a good thing if you can do that, especially if you're embedding graphics or other really cool stuff like the Sage stuff or the JS that we're doing. And the other thing I would say about the accessibility is if you're putting anything that looks like an equation or a number into your text, if it's something that should be an equation, make it be an equation in with the in equation mode, so it's being rendered by MathJax, because MathJax does equations very nicely, and that is a very good thing to take advantage of. Okay, the hints, I put this in mostly because I wanted to re-emphasize that this is a really powerful tool, and one of the things that Vicky says is hints are a very good thing to increase, right, and to improve students' the effectiveness of the problems for the students. Paul talked about this, and so I'm not going to say anything more other than to point out that there are these 2 types of hints. One is the one where you have to load answer hints, and you say with post filter to get the response that is keyed on the student answer, and then the other is you can have something that just shows a hint after some number of attempts as well. And so both of those are powerful things which I don't use nearly as much as I should. So I think, let's see, that is just all this page is doing is comparing the PGML hints with the same thing if you were writing straight PG. But really the only difference is it moves the answer hints piece into an ans call after the text. And other than that, it's basically the same thing. All right, this is solutions. I'm not going to say any more about solutions other than I think that solutions are also something that is a really good idea to include in problems. And in all of these cases, if you do it while you're writing the problem, it's way the heck easier than if I'm trying to put them in. When I do this, if I don't put it in when I'm writing the problem, I never get a solution in there because I don't have the time to add it later. Okay, so this is now where I am almost going to break out of the PDF here. We've said there are all of these resources, and we said basically if you do a Google search, you'll find them. And the two really primary resources that I use are the subject area templates and the index of problem techniques. And so the first of these, Paul is, I think, almost solely, if not solely, responsible for, and he gives you a whole host of really nice basic templates, and they have PG and PGML versions of each of these, and so they give you a way to do essay questions, different multiple choice options, and then templates for different types of problems like linear algebra or calculus and things like that. And then the problem techniques I started writing, and I think now Paul is the resident overlord on those now as well. And these are really great if you say, I want to remember how to do multi-answer, or I want to remember how to do lines or arrows in graphics, then this gives you, the idea is that it gives you a very, very short snippet of how to actually do that. And I'm going to show those both, I think, in just a second as well. The last thing I wanted to say before stopping that was, I've been saying use a template, write your own templates, and so on. What I mean by that is, for me, it's sort of something that looks like one of these two very, very simple files. Right? On the left, it's a very generic template where I haven't filled anything in. And then usually what happens is, if I'm working on a project where I'm writing, say, linear algebra problems, I copy the template, fill in a whole bunch of the tags at the top, fill in a couple more macros that I think I'm going to need, and then uncomment those when I need them in the file. And sometimes I'll even have some sort of header information or information in the text that I tend to be using over and over again, and then I use that file over and again to create the new problems that I'm writing. The other comment I have about writing problems is so I like Emacs for an editor, and so I use Emacs to edit almost everything that I edit, and then I copy it up or upload it into the file, into the course that I'm actually trying to run it in. And so most of the difficult editing that I'm using, I'm doing Emacs, and Emacs has a number of advantages, as many of these do. Right? So I think Vim would also be a great option if you're a Unix person and you're willing to use VI. But one of the things it does is if you put it in the right mode, it actually shows you the trailing spaces at the end of lines and things. And so you can actually see a lot of the coding, the subtle coding things that we've identified as issues with PGML, because you're using an editor that expects those to be significant. If you're not in Unix, then Emacs is harder to get a hold of, though it exists and it's quite good. But the underlying message is that if you have an editor that you like to code in, or you have an editor that works really well, for the bulk of the sort of preliminary coding, when you're not just debugging, you can actually use that and then just copy the files up into the WeBWorK course that you're working in, and sometimes that's going to be faster. And for me, that's way faster because I'm much, much faster in Emacs than I ever am in the WeBWorK editor.